Hey guys, so today we're going to start talking about arithmetic sequences, alright? So what an arithmetic sequence is, the definition of it, is the idea that I go up or down by the same number each time from term to term, okay? So let's look at each one of these sequences, and we're going to determine, one, if they are arithmetic, and then two, what the common difference is, alright? We're going to talk about that, okay? So look here, -5. Then the next term is -3. The next term is -1. The next term is 1. The next term is 3. ... means it keeps following this pattern unto infinity. Okay? What is this pattern? Well, I went from -5 to -3. What is that? That is plus 2. -3 and -1. What is that? That is also plus 2. -1 to 1. That is plus 2. 1 to 3. Plus 2. Do you see how I added 2 each time? So therefore then the common difference is 2. Alright? So this is arithmetic because I went up, I added 2 each time. Okay? If you add or subtract by the same number each time, that makes an arithmetic sequence. Alright, let's look at this next one. 100, 107, 114, 121, ... keeps going to infinity. Plus 7, plus 7, plus 7. Alright, so then the common difference is clearly 7. So D is equal to 7. Let's look at this next one. 1 to 3 is plus 2. 3 to 6 is plus 3. We can stop right there. See how there's not a common difference? This one you added 2, but this one you added 3. Therefore, this is not arithmetic. Alright? So we don't have to worry about this one. There is no common difference. I'm just going to write airy, and you can finish out writing the rest if you want to, but it's not arithmetic. Alright? Again, it's not arithmetic because there is not a common difference. Okay? Alright. So there's a couple things that we find when we're doing arithmetic sequences. I should say there's two different ways we write arithmetic sequences. There is an explicit formula and there is a recursive rule. Go ahead and pause this video and write these down. So both of these ways of writing these arithmetic sequences allow us to find future terms or even past terms, okay? But they do it in different ways. The explicit formula requires that I know what the very first term of my sequence is. It requires that I know the common difference as well, okay? With those two pieces of information, I can write a formula that will allow me to find any term. Alright? My recursive rule only allows me to find the next term following from the prior term. Alright? So what you have to do is you have to know the prior term, and you add or subtract the common difference, depending on what D is, alright, to it, and that brings you to your next term. Alright, we'll do some examples of that. Alright, so we're going to go back to the previous slide, and we're going to find the explicit formula and the recursive rule for those top two ones. Okay, so let's go back here. -5, -3, -1, 1, 3. Alright, so let's find the explicit formula first. Alright, so I'm going to write EF representing explicit formula. Alright, I'm going to write it down again. It was A sub n is equal to A sub 1 plus the common difference, that's D, times n minus 1. Okay? So, I know what A sub 1 is for this problem. It is -5. So I can say A sub n is equal to -5 plus, alright, well what do I know the common difference is? 2. 2 times n minus 1. Alright, now I do a little bit of magic, not magic, I just have to do a little bit of algebra. Alright, so A sub n is then going to be equal to, well you have to distribute the 2n, alright, so that gives me -5 plus 2n minus 2. Now I got to put like terms together, -5, -2. Alright, so I get A sub n is equal to 2n minus 7. Bam. There is my explicit formula. That means that if I wanted to find, let's say I just wanted to find a sub 10. Let's just say I wanted to find a sub 10. Alright? I could say a sub 10 is equal to, well, now I'm going to replace, see how I replaced n here with 10? So I'm going to replace this n with 10 as well. 2 times 10, close that parentheses, minus 7. And so then so this means the 10th term is equal to 2 times 10 is 20, 20 minus 7 is 13. The 10th term is equal to 13. So if I was to continue the sequence all the way out to the 10th term, it would be 13. Alright? Now let's find the recursive rule, which I'm going to call RR. Okay? The recursive rule is simply a sub n plus 1. That means the next term is equal to a sub n, the prior term, plus the common difference. Alright? So then that's going to give me, so this is the a sub n plus 1. So hopefully that makes sense. That by saying a sub n plus 1, you realize that I'm saying, hey, n plus 1, the next term following a sub n, because that would be the prior term, is equal to a sub n, because I don't know what term I'm trying to find, so I just leave n as n, plus, what was the common difference? 2. Bam. That is your recursive rule. Alright? So this is your explicit formula. That is your recursive rule. Okay? So what I'm saying here, guys, is that I could find the next term based on the prior term. So for example, let's say I wanted to find the 1, 2, 3, 4, 5th, 6th term. I could say a sub 6 is equal to a sub 5 plus 2. Alright? And then I know that a sub 5 is 3. And 3 plus 2 is 5. So the next term here would be 5. So the 6th term would simply be equal to 5. Okay, let's do another example. Let's do the second sequence here. Let me erase all this. And let me, you guys should really pause this video right now and try to do this next example. Okay? I do suggest that. Try pausing this video and try doing this one. Find both the explicit formula and the recursive rule. Alright, so the explicit formula. Alright, the explicit formula, that's an E, is a sub n is equal to a1, a sub 1, so that means our first term, plus the common difference, d represents the common difference, times n minus 1. Alright, so then I get a sub n is equal to the first term, which is 100, plus 7 times n minus 1. Because I want to leave n as n because I want to be able to find any term. I'm trying to make a formula that will allow me to find any term. That's why it's called explicit formula. Alright, so then I get a sub n is equal to 100. I got to distribute that 7n. So that's going to give me plus 7n minus 7. So I'm going to get a sub n is equal to 7n. 100 minus 7 is 93. So there you go. So that's the explicit formula. The recursive rule is simply a sub n plus 1 is equal to a sub n plus d. And what is d for this problem? 7. So bam. There you go. Alright. Okay, so let's look at another random example. On this next example, I'm giving you guys a sequence here where you don't know the first couple terms and then you don't know this term. Alright, so we have some gaps. Alright, so what you have to do is find, hey, how is he going from term to term? Okay, so I can already tell you it is definitely an arithmetic sequence, so I'm giving you that piece of information. With that piece of information, you know that there is a common difference. You just have to find that common difference. So, it's not hard to find the common difference, okay? You could just say, you know, well, what do I think it is? You know, you could try to figure out how that works. But here's a very simple way of doing it. Take your later term, so negative 13, minus that common difference, okay, minus any other term that you know. So in this case, I know that's a negative 5, divided by how many spaces are there between negative 5 and negative 13? 1, 2. All right, now, there's those 2 spaces total, divided by 2. So negative 13 minus negative 5 is negative 8. Negative 8 divided by 2 is negative 4. So the common difference is negative 4. Now, with that piece of information, finding the explicit formula should be quite simple. So the explicit formula is just simply going to be a sub n is equal to a sub 1 plus d times n minus 1. Now, you might be saying, whoa, I have a problem here. And you're right. We do have a problem. What is a sub 1? We're going to need to work our way backwards there first before we can find what a sub 1 is. Okay, so then what is the common difference? It's negative 4. That means each time we are subtracting 4. Okay, so then it's pretty obvious to go from negative 5, subtract 4, that's going to give me negative 9. But now I need to go backwards. Okay, so instead of subtracting 4 to go backwards, I'm going to have to add 4. So that gives me negative 1, add 4 again, and that gives me 3. So then I know that I get a sub n is equal to 3 plus negative 4, so I could just write minus 4, times n minus 1. Which then, I distribute this negative 4 in, so I get a sub n is equal to 3 minus 4n plus 4. So then that's going to give me a sub n is equal to negative 4n plus 7, because that's a 4 right there, plus 7. Bam, there's your explicit formula. Your recursive rule is just simple as always been. A sub n plus 1 is equal to a sub n plus d, and d in this case is a negative 4, so just minus 4. Bam, and that's it. That's all there is to this, guys. All right, let me know if you have any questions.